virtual standard switches, now we'll compare virtual standard switches to virtual distributed switches. With virtual standard switches, there is no centralized management. Virtual standard switches must be created repeatedly on each host, which is time-consuming and prone to error. The port groups within each virtual standard switch must be created repeatedly. One example of a common error is failing to recreate each set of port groups with exactly the same names for each virtual standard switch. The names are case-sensitive, and failure to match standard port group names will, for example, cause vMotion to fail. In contrast, vSphere virtual distributed switches are created just once and span multiple hosts. You determine the span of the virtual distributed switch by specifying what hosts to include either during or after creation. Port groups only have to be created once. The port group span is equal to the span of the virtual distributed switch. Any changes you make to the port groups are only made once. To summarize, virtual distributed switches are easier to maintain due to their centralized management. When you create the switch, you create just one, make a change, and make it just once. So far, we've discovered what a virtual switch is, the different types of virtual switches and their capabilities, but you haven't yet discovered how a virtual network is realized. Before that, we'll take a quick look at how a physical network is realized. A physical network is defined or realized by connecting different physical switches to different router interfaces. In this example, Switch 1 supports the 10.1.1.0 network by being connected to interface 1. Switch 2 supports the 10.1.2.0 network by being connected to interface 2. The purpose of dividing the network into different segments is to speed up network performance by minimizing the amount of broadcast traffic on each segment. Broadcast traffic on Switch 1 will not be forwarded by Router 1 to Switch 2 and vice versa. Assuming proper routing configuration in the router and correct IP addressing of the PCs, then PC 1 on the 10.1.1.0 network can communicate to PC 8 on the 10.1.2.0 network. Even though broadcast traffic is dropped by the router, unicast traffic will be forwarded. A network is defined or realized by binding the IP address and subnet mask to the interface on the router. Any switches connected to that interface will be connected, by default, to that network segment.